Question 5.24. Two cars are moving. The first car has twice the mass of the second car, but only half as much the kinetic energy. When both cars increase their speed by 5 meters per second, they have the same kinetic energy. Calculate the original speeds of the two cars. Now, let m1 be the mass of the first car and m2 be the mass of the second. So we will write down what the question has given. M1 is equal to 2 times M2 because it has twice the mass of second car, but only half kinetic energy. So kinetic energy of first car is equal to half the kinetic energy of the second. Now when we increase the speed by 5, when I increase the original speed for both cars by 5, they have the same kinetic energy. So if V1 is increased by 5, and V2 is increased by 5, the final kinetic energy of both cars becomes equal. And the question is asking me to find the original speeds V1 and V2 for the two cars. Now, if I want to find original speed, I need to know how they are related in the beginning. Because whenever the question does not give you numbers, you need to find the relationship between the quantities by themselves. Relationship between speed can be given by the kinetic energy because kinetic energy is half mv squared. Velocity is included in kinetic energy. So I'm going to use this relationship between kinetic energy to find how velocities are related. So let's start with the expression here. We know that initial kinetic energy of first car is equal to half the initial kinetic energy of the second. So write their expression. K1 I will write as half m1 v1 squared equals half. K2 will be half m2 v2 squared. Now m1 is 2 times m2, so let's write that 2 times m2 v1 squared. Half times half will become 1 over 4 m2 v2 squared. Let's cancel the common terms here. I can cancel m2 on both sides, and I can cancel off these 2's because they divide. And we get v1 squared equals v2 squared by 4. Now we can take square root on both sides. v1 will be equal to v2 by 2, or we get v2 equals 2 times v1. Now this is the relationship between their original speed. I can use this relationship in the next part of the question, where we increase the speed by 5. That makes the kinetic energy equal. So let's start with the next part. When I increase the speed of each car by 5 meters per second, their kinetic energy becomes equal. So let's start from here. Final kinetic energy of car 1 is equal to final kinetic energy of car 2. So I can write this as, let's just create partition here. I can write this as half m1 v1 plus 5 squared equals half m2 v2 plus 5 squared. The velocities have both velocities have been increased by 5. So I've written v1 plus 5 and v2 plus 5. And when we do that, their kinetic energy becomes equal. Now we can again substitute the value of m1, which is 2 times m2. Along with that, I'm going to write v2 as 2 times v1 over here. So let's do that. Half 2 times m2 V1 plus 5 squared equals half M2. V2 I will write as 2V1 plus 5 squared. Now let's cancel off the common terms. I can cancel off the 2 over here because they are divided. M2 and M2 can be cancelled. And I can rewrite this as V1 plus 5 squared equals half 2V1 plus 5 squared. Now let's take square root on both sides. V1 plus 5 equals 1 over root 2, 2V1 plus 5. When we take the square root, the square on both the brackets will disappear. And I need to take square root of this half also. Now next you can use shift solve to get the value of V1. Or you can rearrange the terms to find V1. Then we can find what is V2. So you can use shift solve at this step itself. Or you can rearrange with me to find the answer. So I'm going to multiply by root 2 over here. So we get root 2 V1 plus 5 equals 2V1 plus 5. Open the bracket, root 2V1 plus 5 root 2 equals 2V1 plus 5. Now bring the terms together. I will bring the V1 together and the constants together. So let's move this root 2V1 here and 5 here. And when we do that, we change their sign. Plus will become minus. So 5 root 2 minus 5 equals 2V1 minus root 2V1. Now I take the common terms together for V1. And we write 5 root 2 minus 5 equals V1, 2 minus root 2. Now divide by 2 minus root 2. V1 will be 5 root 2 minus 5 divided by 2 minus root 2. When you solve this, you get your V1 as 3.53 meter per second. Once you get the value of V1, I can calculate V2. We already established here that V2 is 2 times V1. I can write V2 as 2 times V1, which is 2 times 3.53, which will be around 7.07 meter per second.